All right. So module 16, part 2, image processing continued. And today we're going to dig a little deeper into the technical details of images, and then I'm going to show you a few things that are maybe a little bit more on the fun side, I guess you could say. And then I'm going to turn you loose to work on the project. It won't take super long. So here we go. I want to go a little bit deeper into the RGB color model by way of review and then adding some more information. So here are the RGB as primary colors, and you can see red, green, and blue as they overlap create cyan, magenta, and yellow. That's why printers use cyan, magenta, yellow, and black as their primary colors, because it's the inverse of our color model. So red, green, blue are the colors of light that when combined at full strength produce white. And we have 256 times 256 times 256 possible colors, which equals 16,777,216 possible colors. This cube is sort of a way of looking at those color relationships. Now, obviously, this is not 256 by 256 by 256. It's actually just 6 by 6 by 6, which is whatever 36 times 6 is. It's 190 something, 90 whatever, somewhere in that neighborhood. So this is what if you were mapping a cube, and if you can imagine that on one side of the cube is this, and then if you turned it around 180 degrees, the other side looks like this. So as we go from full strength of everything, we get white. And as we move toward the corners, of course, we've got our primary colors and then the secondary colors as well, cyan, magenta, and yellow. And then if you look at the other side, obviously that's the same thing. If you want to see all 16 million colors, this image actually contains all of them. 1 pixel of each color. It is 256 times 256 times 256 pixels. So that is all the colors. And I take this one image just to show you how big this image actually is from a pixel standpoint. If I take this image, if I take this square and zoom in all the way, so it looks like this. And then I take this piece of this square and I zoom in all the way. Each one of these pixels is a different color. You can't really see the pixel lines very well. You can kind of see them. If I zoom in, you'll be able to see them better. But each one of those squares is a slightly different color. So that's how many colors we're actually talking about. So now it seems like a lot, right? 16,707,000, almost 17 million colors. That's quite a few. Still not as many as we can see. So when we talk about pixels in an image like this pixel is in that image. That color that I just showed you, that image I just showed you, contains this color. It also contains this color. It contains all of these colors because all of those are part of that 16.7 million color palette.